Okay, a couple of announcements before I get started. Test 1, 2 weeks from today on a Wednesday in the evening from 7 to 8:15. Location will be announced later on, so please take note of that. Homework grading. Moving forward, we'll only grade one problem of the whole set. For example, what's due today, which I will not collect. Anytime I have a quiz in class, which we will today, don't upload the homework because Mike is busy grading a quiz and we will not grade the homework for that particular lecture. But moving forward, the whole set of homework, 3 problems here and here, only one will be picked up randomly for grading. And if you haven't done that problem, you will not get any credit. All right? So quiz, what I will do is to pass out the question sheet face down. So don't look at it until I tell you to. We will have a quiz somewhere in the middle of the lecture. And after you're done with the quiz, make sure you have your name on it. Take a picture. Take a picture and upload that to Canvas. With all that mechanic, I will give you maybe, the quiz itself is like 3 minutes, maybe 5 at most. But I'll give you 10 minutes just to go through all that mechanic. Is that clear? Any questions on the quiz? Quizzes are unprepared. You will find that they are forgiving. As long as you stay on top of the lecture and the homework, there's no reason you cannot do the quiz. And there's really no preparation you need to prepare for the quiz. For the agenda today, we're going to continue to work on the momentum with a new twist. We are preparing you for working 2-dimensional problem, which is very complex and at times confusing. And before I do that, today is the last lecture which I will wrap up everything about the 1D problem, the homework set due today, and the quiz, as well as the homework set due next time. And then moving forward, we are starting to deal with 2-dimensional problems. So if you have a problem with 1D problem, now is a good time to ask and clarify any problem you have. There are many places for confusion, so I want to make sure I slow down and have that absolutely clear before we go to 2D. With that, I will finish any question you have on the old homework that are due today. And I just want to make sure that you are all on top of it. Again, solution will be posted right after the lecture. And the new homework 3 problem is about 3 hours. I will again touch on each one of them very briefly, just to give you a taste of what is being asked. Quiz in the lecture today, and we will start to look at what is called the Reynolds transport theorem. That's an equation that takes a system equation like F equals ma and convert that to a control volume of the momentum equation on the left. So that's a beautiful agenda. Depending on how many questions you have, make every attempt to slow me down. Reading, posted on Canvas is a 4-page handout on a very elaborate 2-dimensional problem that I call plate. So please read that in preparation for the lecture on Thursday. What I'll do in the lecture is to go walk you through that piece by piece, component by component, to look at XY momentum equation. In addition to that, there are 2 example problems in the text in chapter 5, example 11 and 12, that I'd like you to also read out. That is exactly the same problem as in your homework, which is due on Thursday. That's the 3 problems in the old edition 38 of chapter 5, in the old edition 39 of chapter 5, and the new edition problem 45. All right? So the homework is very easy if you look at the example and try to look at the differences and also some of the detail that I will lay out during the lecture today. Try to kind of get things clarified so you can fumble. And then the next set of homework is still a week from today. All right? So we're kind of preparing ourselves for the test, which, as you may expect, is continuity, momentum, mainly the most important and most difficult concept in fluid. Any question before I start? On the logistics. Yes?
So after the quiz, we take a picture and then we upload it in place of the homework, like under the homework in Canvas?
No, no. Can we do it? Mike, do you know the answer to that? We want to upload the quiz if there's a checkbox for quizzes.
I'm just going to create an assignment, and then you guys can all upload it to the assignment, just like a regular homework. But it'll be a separate assignment.
Yeah. the quiz will be counted and weighted differently than the homework. So if there's any question, don't worry about it, upload it, and then we'll deal with that. Okay? So we have looked at this very simple problem. I use it as an anchor to elaborate on the X momentum equation, just like we did with the continuity with filling the water tank. It's very visible, it's very relatively easier to grip yourself around this simple-minded problem, and then we work out all the algebra, we look at how to define the coordinates, how to define the control column, and we come up with the answer. So I assume by now, most of you have no question on this type of example. So it's a free jet. What is the pressure inside the jet? Atmospheric. Does it matter whether it's water or air? Is it still atmospheric if it's a water jet versus the air jet? Yeah, same. The fluid is inconsequential. Free jet is always ambient. All right? And the pressure acting around this entire control volume at net 0 forces due to pressure, because everywhere is ambient. With that, we introduce the so-called X momentum equation. And I put the X here because the momentum equation, as such, is a vector equation, and hence the overbar or the arrow over the force and also over the acceleration, which we have rewritten into this form. So what is the product of mass times the velocity? Momentum. Yes, this is momentum. Is this a vector or scalar equation? Do you know what that means? I asked that before. Anyone? It's a vector. What does that mean? Does the direction count? Is it important to tell me the direction of which you're using the force? Yes. Yes. Compare that with continuity. M dot, mass flow rate. In the simplest form. Is continuity a scalar or vector equation? Scalar, very good. So please make that small distinction, but it's important. Vector now have how many components in general? In a real life problem, like if you're asked to analyze the flow inside that gas turbine engine in the atrium, how many directions? We only have to deal with one, right? X. But in real life, how many directions you could deal with? Three. X, Y, Z. So I need to now introduce you the Y momentum equation. The momentum equation perpendicular to X, and then there's another one is Z, which we will deal with next time. I'll make a wild guess as to what that equation will look like in the Y direction, signed with the right-hand side. F sub Y, yep, very good. Now I have to account for all the forces in the direction perpendicular to X.